Modern technology has never matched the simplicity and grace of a traditional pen. In fact, you could say that there is no equal. Get it? Equal, like a quill, a pen. My name is Paul Pazulka, Ivy Masters Learning Center at IvyMasters.com, and today we're going to look at the October 2020 SAT, Section 3, number 10. Number 10 reads, in the XY plane above, point F, not shown, is placed so that triangle ABC is similar to triangle DFE. Which of the following could be the coordinates of point F? So, you might look at this and be like, oh, like this is really difficult. As long as you know that similar triangles are basically, they're the same angle measures, they're just different sizes. And then you could use your answer choices. Remember, that's one of your two biggies. You could either pick numbers or use your answer choices. For this one, we'd use our answer choices. And all we're going to do is we're going to plot points and see what looks similar, what looks like it's the same exact shape as a smaller triangle. If we have more than one possibility, then we're going to do some counting. And that's really it. So answer choice A is 0.36. So you can see the origin is here. If I go right 1, 2, 3 and down 1, 2, 3, 4, 5, 6. Our triangle is going to look like this. And you can say, hey, does that look similar? It probably doesn't. Another is 4, -10. If we go 1, 2, 3, 4 and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's down here. That triangle's going to look like that. Does that look similar? You'd have to ask yourself that question. And then 6, -7, 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6, 7. We're right here. And then we've got 6, -1, 1, 2, 3, 4, 5, 6, and we've got down 1. So it's right here. So you may be able to eliminate some answer choices based on this. Now, let's look. Here's our second option here, which is there's going to be something called scale factor with similar triangles. In other words, what you're trying to find is that how many times bigger is the big triangle than the small triangle. And what we see, let's just look between points A and C. From A to C, you go up 1, and you go over 1, 2, 3. So that's got to be the same ratio of rise over run or drop over run or something like that as our triangle. And if we see between the 2 points that were given already, between D and E, you'd go down 1, 2, and run 1, 2, 3, 4, 5, 6. So, how is that helpful? It looks like the scale factor for the big triangle is double the small triangle. So for the small triangle, let's look at another side. We could rise 1, 2, 3, 4, and run 1. So if we're rising 4 and running 1, that would be like rising 8 and running 2. Or in this case, it looks like our triangle may be upside down. So I'm going to check from here. If I go down 1, 2, 3, 4, 5, 6, 7, 8 and run 1, 2, it looks like this is going to be the spot for my coordinate. What I could also do is I could check from the other side. The other side of the small triangle, I rise 1, 2, 3 and run 1, 2. So it's that ratio of 3 to 2. So this should be a ratio of 6 to 4 if it's double. Let's see. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. And in fact, it is. So what's this coordinate? It's 1, 2, 3, 4, and then you wind up dropping 10. So 4, -10. B is your correct answer. Thank you for joining us today. If you like this video, click like. You can share it with someone who has trouble with this type of question. Not super common, but it's coming up on some more recent tests. So any question you'd like to see answered from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. And click subscribe so you don't miss anything. Have a great day.